Welcome to One Chemistry. Always try to do your best. Now we are going to see Sharpless reaction. It is asymmetric synthesis. We are going to see some basics and some tricks and some solved problems in the examinations. Stay tuned. What is inside this video? Inside this video we are going to see what is Sharpless reaction and basics and tricks and fully solved problems from NetGate, JAM and TAFR. We will learn it from some prominent examples and problems. At first, let us see what is Sharpless asymmetric reaction. It is a conversion of alkene into epoxide. The reactant is kind of prochiral. The attack can be on above and below. Here we are using titanium isopropoxide as a catalyst. Peroxide is the oxidant and the chirality created by the ligand, which is TET. TET is a triethyl tartrate. Based on TET, you will form above or below the plane epoxide. So what the reaction is really about, finding the epoxidation, you have to find whether it is above or below. The reaction is all about enantiomer selectivity. Before we get into further detail, you have to know OH position is crucial for the selectivity. First you have to bring the double bond vertical straight line, then you have to bring OH also above. Then you have to find OH is left side or right side. It is very crucial for deciding the mechanism. Once you find the OH position, then you have to decide the enantiomer selectivity by DET. Here I given the table. The table can suggest you alcohol right plus DET mean above the plane epoxide, alcohol left mean below the plane epoxide. It will be vice versa for minus DET. You will have alcohol right mean below the plane, alcohol left mean above the plane. So let us learn from the first and second example. First example, double bond is not vertical. You bring the double bond vertical. So OH is left side. You are using minus DET. So minus DET left side mean above the plane. Then you have next example. Again you have to bring the double bond vertical. You have left side OH and you have plus DET. From the table you can find epoxide is below the plane. So OH position and DET decide the enantiomer selectivity. Here it's a trick or mnemonics to memorize the reaction. Always you confuse plus and minus DET, alcohol left or right. So you have to remember the word para. Para means plus DET, alcohol, right position and above the plane epoxide. The other things will be reversed and vice versa. So you have to remember the word para. From that you derive the required information. Let us learn from the problems, because the problems help you to understand the reaction completely. It will give depth to your understanding. Let us see the first problem. Here they given the allyl alcohol. As per our theory, you bring the OH left, you have plus TET. OH left plus TET, you have below the plane epoxide. It is that easy. You have to remember the table. Then let us look at the next example. Starting with a cyclic system, allylic position in the side chain. So the alcohol is right side, you have plus DET, so it will be on above the plane epoxide formation. So the double bond form above the plane of the ring. Let us look at the next example. Here starting middle allylic alcohol with side chain benzene ring will attached with fluorine. It's a kind of distraction. You have to only see the position of double bond. As per our theory, bring the double bond vertical. Then you have to find OH left or right. Here OH is left. Then minus DET. OH left minus DET, it will be above the plane. So you just draw the epoxide above the plane of the allylic system. Then let us look at the next question. The starting metal with exocyclic double bond. The ring contain double bond and double methyl system and OH in the side chain. Already double bond is vertical, so OH is left, minus DET, so epoxide will be above the plane. Then let us look at the next example. You have allylic alcohol attached with 5-member heterocyclic ring with 2 oxygen and methyl group. So you have to bring the double bond vertical here. OH comes left, you are using minus DET. Minus DET, OH left side, you have above the plane epoxide. From this you understand that side chain never contribute to our reaction mechanism. So only you have to guess OH is left or right. Then the next example, you have two kind of alkene system with alcohol. Here epoxide only happen to allylic system, not with the alkene, the isolated alkene. As per our theory, you have to bring the double bond vertical, OH left, minus DET, epoxidation above the plane. So the fact here you have to know here is only allylic double bonds gets epoxide. Then let us look at the next question. The starting metal is chiral compound with chiral center near the ring and you have side chain allylic double bond. Here you have to find the product. As per theory, you have to bring the double bond vertical. Hence the whole ring comes to the vertical position, OH left plus DET. So you have epoxide below the plane. So the fact here is chiral center not disturbed by the reaction. Then let us look at the next question. Here you have allylic double bond with silicon system. Here silicon system is there, same way the OH group which is in the allylic position. Here don't confuse with the silicon given for distraction. So OH is left minus DET, so epoxidation above the plane. So the fact here is epoxidation can work in the silyl system also. Then let us look at the next system. You have allylic alcohol system, but the trick here is alcohol is below. See, even though double bond is vertical, alcohol is below, you have to bring the OH above, then only our theory works. So OH left side plus DET, so answer will be below the plane. So you have to always bring the OH above, otherwise your answer will be wrong. Then let us look at the next question. The starting metal is the alkene with OH in the allylic chain. You have to find the product. Here again the same problem. Bring the OH above by rotation. Double bond already vertical. So OH is on left side. OH left side minus DET. So epoxy will be above the plane. So you have to bring always OH above here. Then the bonus question. The allylic oxidation also work in the terpene kind of architecture. Here OH is there, allylic kind of system, and the isolated double bond. Only allylic OH will react. So you have to bring the double bond vertical, then plus DET. OH left plus DET. You have epoxidation below the plane. So you have to bring always double bond vertical. OH is on above the plane. Let us summarize what we seen. Always you have to bring the double bond vertical and bring the OH above, then only our theory will work. Then you have to know alcohol position and DET decide the position of the epoxide there. The mnemonics is para. Para stand for P per plus DET, alcohol, right side and above the plane. That's all for now. Thanks for watching. If you have any suggestion, comment below. If you really like my video, do share and subscribe.